Okay, good morning to one and all. Today we have to start with the new unit of the analytical chemistry. Hello. Today we have to start with the method of separation. In the method of separation, we have to talk about the two particular techniques: solvent extraction, and then the that particular you can call it as a chromatography. Okay. In the solvent extraction, we have to talk about liquid-liquid extraction. It is a method based on the separation of the liquid. It is a method of separation based on the distribution of the solid between the two immiscible liquids. This is a technique in which a solution is brought into contact with second solvent which is immiscible with the first. अभी ये that totally depends upon the Nernst law. That things are very much depend upon the Nernst law. Okay, Nernst law क्या है that we will see, or say you can call it as the partition coefficient. ये जो चीजें है liquid liquid separation जब करना होता है, that is depend upon the partition coefficient. This is the technique in which a solution is brought into contact with the second solvent. अभी solution aqueous है, and that will be brought in contact with the second solvent which will be the organic and which is completely immiscible, and that should be immiscible with the first one. The separation can be achieved by this way, are simple, convenient and rapid to perform. The solute transferred or extracted into the organic solvent is later recovered from it by evaporation or other method. Then the distribution constant and the partition coefficient or distribution coefficient, that is a very much important term which is required as for this particular extraction of this solvent. This particular you can call it as a liquid-liquid separation. See, the distribution of the solid between the two immiscible solvent is governed by distribution law. The distribution of the solid between the two immiscible solvent is governed by the distribution law statement. According to this law, a solid will distribute itself between the two immiscible liquids in such a way that the ratio of concentration of equilibrium is constant at a particular temperature. That K is equal to C1 by C2 is equal to C0 by aqueous, and distribution ratio D is equal to C1 by C2, where C1 and C2 are the concentration of the solute in all its forms in the two liquids. D is a dimensionless. D at a given temperature is constant and independent on the total number of this particular total number of solute. Now separation factor. Extent of separation. The extent of separation can be found by quantity called as a separation factor, which is related to distribution ratios of A and B by the equation. Beta is equal to A0 by AW divided by B0 by BW, that is a dA upon dB. मतलब A component के लिए aqueous, okay, and organic. ये W मतलब water में, O मतलब organic में, okay, dA by dB. When dA is equal to 10, dB is equal to 0.01, then the separation factor will be 100%. The separation effect increases with magnitudes of separation factor. If the separation factor is large, but the smaller distribution ratio is also appreciable, then extraction of the both components occurs. Okay. Then if the separation factor is large but the smaller distribution ratio is also appreciable, then the extraction of the both the component occurs. For a given value D and dB, the separation effect can be increased by adjusting the volume ratio which is given by the Bush-Denson. That Bush-Denson equation as Okay, Bush tension equation is that V0 upon VW is equal to 1 upon dA into dB raised to half. Half मतलब अंडर रूट है. Okay. फैक्टर्स अफेक्टिंग द एक्सट्रैक्शन. अभी यहाँ पे कौन से फैक्टर्स है? चिलेशन है, द प्रोसेस ऑफ आयन पेयर फॉर्मेशन है, प्रोसेस ऑफ सॉल्वेशन है. Okay, solvent extraction of metal ion is based on the formation of an uncharged complex followed by the distribution of it between the pair of immiscible solvent. This complex may be produced by chelation. This is formation of the coordinate covalent or dative bonds. The process of ion pair formation, process of solvation. चिलेशन में अभी क्या होता है? चिलेटिंग लिगैंड जो रहता है, चिलेट फॉर्म करना मतलब रिंग स्ट्रक्चर फॉर्म करना है. सिंपली ये ध्यान में रखना है. दिस इज नथिंग बट अ okay. Chelating ligands have a vital role in extraction of the metal. The substance which brings about chelation is called as a chelate or complexic agent. That is, metal ion plus chelate agent gives you the metal chelate. The chelates are classified according to the types of basic group present. If both the basic groups are unchanged, it results into positively charged metal chelates. If the reagent has one ionic group, neutral chelate is formed. If there is a multiple negative charge on chelating agent, results in negatively charged chelates. Neutral chelates are easily extracted into the organic solvent. Aluminum ions in solution are usually converted into the hydroxyquinolate. By the addition of this HQ, that HQ ये short form है, generally HQ लिखा जाता है. HQ is nothing but the 8-hydroxyquinoline, जिसे इन शॉर्ट उसे ऑक्साइम भी कहा जाता है. ब्रैकेट में इसे ऑक्साइम भी कहा जाता है. The chelate formed by this is extracted by using benzene and chloroform. Al is only extracted at pH 5.8 in the presence of the iron, nickel and vanadium. The equilibrium is as follows. NHQ plus Mn plus aqueous gives you MQN organic plus NH plus aqueous. The equilibrium is depends on H plus ion concentration. Hence pH control is necessary. Other complexing agents are also used such as dimethylglyoxime, acetylacetone, pifron, alpha nitroso, beta naphthol and dithiazine. Acetylacetone forms a stable chelate with the more than 60 metals ion. DMG is used for the extraction of the nickel and the palladium. The formation of the complex of metal ion occurs due to tendency of a metal ion to acquire lone pair of electron from the ligands in its vacant atomic orbital of appropriate energy and symmetry. It may be unchanged or charged species. The complex of metal ions with monodentate ligand don't possess ring structure. Example CuH2 2 plus. The complex of metal ion with polydentate ligand possesses ring structure are called as chelates. which are more stable. Example is given to you. इसे चिलेट्स कहते हैं. रिंग स्ट्रक्चर फॉर्म होना चाहिए. And here the Mn plus is there along with the ethylene. Okay, En is nothing but the ethylene. You can see the 2 point of that सी. यहाँ पे क्या हुआ है देखो आप, मेटल के साथ ये कोऑर्डिनेट बॉन्ड फॉर्म किया है. एरो जो है, दैट एरो रिप्रेजेंट्स द फॉर्मेशन ऑफ द दैट पर्टिकुलर कोऑर्डिनेट बॉन्ड. ये कोऑर्डिनेट बॉन्ड कहते हैं. तो इट फॉर्म्स द रिंग. एंड आयोनिक चिलेट्स आर जनरली यूज एज sequestering agent to mask the cation during extraction. The effectiveness of the chelating agent to form stable metal chelates depend upon, अभी किसके ऊपर डिपेंड है? The basic strength of the donor, then the electronegativity of the bonding atom, size and number of the chelate rings. These are the whole about the chelation. Then process of the ion formation. अभी जैसे कि 2 लिक्विड है, ओके, वहां पे that particular formation of these things, ion pair formation will be there. Ion pair formation takes place when a reagent having large organic ions such as tribenzyl, ammonium ion or high molecular weight amines. Tribenzyl. Okay, these reagents combined with suitable metal containing ion to give a large organic solvents like ion pair. As compared to solvation, solvent molecules are involved in the ion pair formation. The large ion extraction system lacks specificity because any relatively large unhydrated univalent anion will extract only large. The large ion extraction system lacks specificity because any relatively large unhydrated univalent anion will extract only large univalent sorry, here should be the cation. Will extract only large univalent anion. Polyvalent anions have large hydration energy and hence they are not easily extracted. Chelating agent having 2 unchanged donor atoms such as 1,10-phenolphthalein form cationic chelate complex which are large and non-polar. 3-phenolphthalein ion 2 perchlorate get extracted easily into chloroform and extraction is virtually complete using large anions such as long chain alkyl sulfonates ion in place of the ClO4 और से perchlorate. ClO4 को क्या कहते हैं? Perchlorate. The extraction process is given by the following equation: R3N organic plus H plus A minus gives you R3NH plus A minus. That will again यहाँ पे B है वो replace कर रहा है. ओके, पहले extraction हुआ, उसके बाद में anion extraction is there. ये anion है, sorry, anion ही चाहिए. The large ion extraction system lacks specificity because any relatively large unhydrated univalent anion will extract only large univalent anion. Anion exchange will be there. Okay. The process of the solvation. The solvation is the association of solid molecule with the solvent molecules. In the extraction by solvation, solvent molecules are directly involved in the formation of ion association complex. Oxygen containing solvents like ether, esters, ketone and higher alcohols have coordinating ability which is important in extraction process. Such a coordinating solvent facilitates the extraction of metal nitrates, chlorides by contributing both the size of the cation and resemblance of the complex to the solvent. Example, that tri-N-butyl phosphate is widely used as a solvent in the extraction of uranyl nitrate. Extraction of iron from the hydrochloric acid solution in the aqueous phase exists as chloro complex FeCl4- in the presence of organic solvent ether. The species extracted into ether as that reaction is given. Just we will complete. Organic solvent and dielectric constant less than. Wait a minute. Constant less than 40 shows appreciable ion association solvent. Extractable species are formed with the neutral extraction having donor atoms like oxygen, sulfur, nitrogen, which can solvate directly the proton or metal atom. Example, extraction of uranium by ether and methyl isobutyl ketone from nitrate solution. ये हुआ आपका solvation. We will see again that concept. Here we will stop.